Hello Curiosity Cadets, we are going to be talking about your instant weight loss formula. Da, da, da. This is coming in this month's Atomic box and we're exploring atoms obviously, and this instant weight loss formula sounds a little bit like magic, a bit spooky, but it's not, it's just science. And what we're going to be measuring the weight loss of are some fizzy vitamin C tablets. Now I love these tablets. You can do so many cool science experiments with them, and you don't need all of them, this whole tube worth, for this experiment. So I really encourage you to try some of your own ideas, have a think about what you want to do and see what reaction you get using these tablets. And the reason they're so cool is because they fizz, and that is where we're going to measure our instant weight loss. So inside each of these tablets there is citric acid and sodium hydrogen carbonate. Now, when you mix those two things squashed into this tablet with water, what we get is water, carbon dioxide gas, and citric acid. Sodium citrate. And it's the carbon dioxide gas that we want to measure. That's going to be coming out of these tablets, and we're going to see, as we use our lovely little pocket scales here, we're going to see how much carbon dioxide gas there is in these tablets. So we're only going to be measuring something, it's a gas, so it's really light. So we're going to be measuring tiny changes in the weight of your chemical reaction. And as I said, you're going to be using these cool little pocket scales. Now, one top tip, the only buttons you're really going to need are the on and off button, obviously, and the tare button. Now, what tare does is it takes it back to zero. So when we want to measure out our our vitamin C tablets, our fizzy tablets, we don't want to know the weight of the vitamin C tablets and the cup. So if we put the cup on, press tare, it takes it back to zero, we pop our tablets in, and we know that we're measuring just the weight of the tablets. And that's really important because that will help us to be super accurate, which is what scientists need to be, when we're measuring the weight loss that we're going to be getting. So as I explained, we're going to be measuring how much carbon dioxide gases can be liberated, can be created out of these tablets, or converted from the ingredients in these tablets into that carbon dioxide gas. The next part of the experiment is to add some milk powder. So this has got lots and lots of protein in it, and to see what difference you get when you add the milk powder into the solution, it's going to be really interesting, because I don't know what you think, but I thought it would just be kind of the same, that it would bubble up and the gas would escape, and then we'd see the difference in that as well, in the same way as we do with the others, with just plain water. But actually the protein in the milk powder acts a little bit like a trap, and it's they kind of link together, the proteins link together like this, and they create almost like a coating around that gas bubble. So like when you put washing liquid and you bubble it up and you can see the bubbles coming out with washing liquid, actually the gases that are escaping in there, or the air that's around that or is trapped in that, would be exactly the same if the washing liquid wasn't there, but the washing liquid traps the bubbles in because it's very flexible and bendy. And this is kind of the same. Those proteins create a shell around the bubbles of carbon dioxide gas that are coming out of our chemical reaction, and they stop them being able to burst. So rather than bursting and going off up into the air and us being able to measure how much goes up into the air, we can't, because it stays trapped in a bubbly foam inside your cup. So if you think about that, that's because of protein. What your challenge is to go and have a think, what other things could I try my fizzy tablets with could I make more carbon dioxide gas escape? Could I make the weight loss even greater? Is there something that could make it almost zero? Is there something that could trap it so tightly in? And most importantly, and this requires a little bit of preparation because it could get a little bit messy, is there something I could do that could create an even bigger foamy froth? And if you find something that gives you a bigger froth than our milk powder, I'd love to know about it. Good luck and have fun.